Hi, okay. So we are going through our next lesson. Make sure you guys are writing this down and actually listening to this. So what we're going to be doing is we're going back to graphing. We're graphing radical functions. So first off, remember that a function means each x gets one y. So when we graph these, each x is only going to get one y. And then just a fun fact, I have a cat named Gus, just something to throw out there. First one we are going to graph. So we are having some parent functions. Our first is a square root function. So this is our parent function. Now the fact that it's a function, one thing I want to point out, normally when we have a square root, we have a plus minus, right? But if we use that plus minus, that means everything is going to give us two answers, because like a positive and the negative. So to make this a function, we are only considering the positive root. So just know like a function just means only one answer for each x. When we start these, we're going to start just by making a table. So a normal number to plug into our table to begin with would be 0. So as I plug that in, I'm plugging it into this equation right here. So the square root of 0 is 0. Next number, 1. What's the square root of 1? 1. Now 2. If I were to plug in a square root of 2, is that going to be a nice number? No. So we're going to skip that. Let's pick numbers that are nice. So 3, that wouldn't be a nice number. But if I plug in a 4, what's the square root of 4? 2. What would be the last nice number that we could plug in? 9. The square root of 9 is 3. Now, normally we also plug in negative numbers, but if our goal is to graph this, would we be able to plug in a negative number and get something that we can actually graph? No, we can't. So no negative numbers. I'm just going to make a little sign right here. No negative in the table, because we can't take the square root of a negative number. So when we graph it, we have 0, 0. And then pattern-wise, 1, 1. Plug in a 4, we got out a 2. Plug in a 9, get out a 3. So this equation, this function, the square root function, is half of a little arc. Now technically the plus minus would mean there would also be this minus. The minus would be underneath it, but that would not be a function. So we have to restrict our domain so that we only have the positives. And then this table right here is our side pattern. Notice how like the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The next number would be like 16. So the square root of 16 would be up 4. This graph has an endpoint. The endpoint is at 0, 0. All parent functions start at 0, 0. Domain is always left side, right side. So on the left side, it gets cut off at 0. On the right side, it goes forever to infinity. Your range is always the bottom to the top. So the bottom of the graph gets cut off at 0. The top of the graph goes forever to infinity. So this is our first parent function, the square root function. Notice we have no negatives in the table because we cannot take the square root of a negative number and get something that we can actually graph. The next one we are going to have is the cube root function. So cube root function, we're going to start by making our little side pattern, 0. So the cubed root of 0 is 0. Next number to plug in would be a 1. The cubed root of 1 is 1. If we were to do like the cube root of 2, that's not a nice number. So if you look on your yellow sheets, the next nice number is going to be 8. Because what's the cubed root of 8? It's 2. So the one thing that's different about a cube root, remember negatives can come out of a cube root. So this one, negatives are okay. Because if I plug in a negative 1, the cubed root of negative 1 is just negative 1. The next number would be negative 8. The cubed root of negative 8 would be negative 2. As we are then looking at this one, so the ordered pair negative 8, negative 2 when we graph it, so negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. This graph kind of looks like a sideways S curve. The table pattern is all of that. I usually skip the 0, 0 just because that's already like your middle point. But this graph has a turning point in the middle. So we can see it kind of turns in the middle right there. The domain, left side, right side, there's arrows on both sides. So it never stops to the left. It never stops to the right. Range-wise, this one is going to keep slowly going down. This one is going to keep slowly going up. So again, down forever, up forever. So domain and range always will be the infinities on the cubics because they keep going forever. When we look at these, we're really just going back to transformation rules. So both of these, the variables always do the same thing. If you ever have something inside with x, it's going to go either left and right, and it's going to go opposite the sign. At the end by itself, that k value, remember if you have something that's adding at the end, that either goes up or down, and that follows the sign, so it has the same sign, so plus goes up, minus goes down. And then remember a values in the front, change your sides, and it always multiplies the second part of our table. So when we graph these, hopefully it seems pretty familiar because we're just going back to transformation rules. We just have a different shape that we're doing it with. Probably the easiest way to graph these is step one, find that like endpoint or middle point. So we have a square root function, but it doesn't change how we start. So inside with x, we see we have a -4, so we know that's going to take our graph right 4. Outside at the end by itself, we have a +2. We know that will take our graph up 2. So we know our starting point is over 4, up 2. So right 4, up 2. Translate your end or turning point. Translate, this just means your left, right, up, down. Your end or turning point, that's your first step. After that, you want to put on your sides. So your sides are based off of whatever your parent function is. This is a square root. So this is our side pattern. So our side pattern of a square root is I go over 1, the square root of 1 is 1. I go over 4, the square root of 4 is 2. I go over 9, the square root of 9 is 3. So it's very similar to a parabola, but now it's backwards. So make sure you are taking a square root when you change it. So 1, 1, 4, 2, 9, 3. So that means from this point that I went left 4, up 2, I'm going to go over 1, up 1. Just on the one side because we can't have negatives. 4, 2, over 4, 1, 2, 3, 4, up 2. Last one, 9, 3, means I'm going to go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So when you graph a square root, it should be like half of a little hill. It has an endpoint. The endpoint is that starting point that you move right away, the right 4, up 2. Your domain always goes from the left side to the right side. So if we look at this graph, to the left side, we have our 4. To the right side, it goes forever to infinity. Your range is always the bottom to the top. So bottom-wise, the bottom is at 2. The top goes to infinity. And remember, the bracket just means it's a number it can actually equal. The last thing, when we put on our sides, we had no number in front. We had no a value. That's why our side pattern did not change. All right, let's do another one. So same process where whenever you are graphing, step one is always start by translating that middle side point. So inside with x, we have that +3. So inside with x +3 means we're going to go left 3. Outside at the end by itself, we have this -1, so we're going to go down 1. So our turning point, everything always starts in the middle. This one is going to go left 3, down 1. I'm going to put this in a different color just so you guys can see. That middle point, the turning point, is where everything starts from. So you find it the same way regardless of what your parent is. What changes now that this is a third root is that pattern. So if you want to start with the positive, start with the positive. So 1, the cubed root of 1 is 1. 8, the cubed root of 8 is 2. Because it's a cube root, negatives are okay. So the cube root of -1 is -1. The cube root of, that's my cat, -8 is -2. Here's my cat. Hi, cat. Yep. Bye, cat. Thank you. See you later. That's not Gus, that's Minx, by the way. Okay, so our pattern. -8, -2, because the cube root of -8 is -2. -1, -1, 1, 1, 8, 2. This pattern is the pattern for every cubic to begin with. After we know our pattern, again, this is every pattern for the cubic, we look to see if we have a number in front. Numbers in front always change the sides. This would be a stretch by 2, but in practice, numbers in front always just multiply the second part of your counting pattern. So -2 times 2, -1 times 1, 1 times 2, 2 times 2. So our new counting pattern is going to be, I go back 8. So this -8 means go back 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 4. 1, 2, 3, 4. -1, -2. So from this middle point where we moved first, go back 1, down 2. Go back to this middle point, our turning point. Now we're going to go ahead 1, up 2. Back to our middle turning point, go ahead 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, up 4. So when we connect them, it's still that like S shape, but do you see how it's stretched out in the middle? It's more vertically stretched. Domain-wise, left side goes forever, right side goes forever. Range-wise, bottom, this is slowly going to go down forever. Top is slowly going to go up forever. Domain and range will always be the infinities on a cubic. Okay, next one. So when you guys graph, step 1, translate that middle point. So we have nothing inside with x, but then this +7 is at the end, so it'll go up 7. So nothing, so it doesn't go side to side, it just goes up 7. So our endpoint is 0, 7. So the endpoint just means, since this is a square root function, it's just called something different, but it acts the same way. It's just where you start. So this is where everything is starting from. Now we have to make our table. So it's a square root. So the square root, we can't take square roots of negative numbers. So we start with 1. The square root of 1 is 1. Then we go to 4, because the square root of 4 is 2. Then we go to 9. We're picking nice numbers, so we can actually take the square root of them. The square root of 9 is 3. And then just for fun, we're going to go one more. What would be the next number we could take the square root of? It's 16. The square root of 16 is 4. So whatever you plug in, you just take the square root of it because it's the square root function. After you have your pattern, you look at the front. Anytime you have anything in front, it always just multiplies the second part of your pattern. So -1/4 times 1, -1/4. Whenever you take a fraction times a whole number, it just multiplies on top. So like 2 times -1/4, because we're multiplying, -2/4, which is -1/2. That gets weird to see. -1/4 times 3, -3/4. Can't reduce that. -1/4 times 4, again, the top number multiplies, the bottom number stays the same. -4 divided by 4 is -1. So when we see 1, -1/4, 1 means go ahead 1, -1/4 means we're just barely going to go down. So negative on the second number means go down. Now we're going to go over 4, 1, 2, 3, 4, down a half. So again, barely going down. Over 9, down 3/4. So we're still not even to 1 yet. And then last one, it would be over 16 and then down 1. So you can see with that 1/4 in front, the negative flips it. And then the 1/4, instead of it being like a bigger hill, do you see how it's like barely sloped? Once you have your graph, domain, left side is at 0. We have to use our numbers here, so it's hitting 0. Right side goes forever. Range, bottom first. So bottom, this thing is slowly going to go down forever. And then the highest it's going to reach is at 7. Okay, last one. Step 1, move your point. So in the middle, or inside with x, we have a +2. So that'll take us left 2. Outside by itself, we have that +4. So then we go up 4. So we start by going left 2, up 4. We then look to see what kind of, it's a cube root. So you can take the cube root of a negative number. So this one does have the negatives. The cube root has the negatives. Start with a 1. Cube root of 1 is 1. Next number is an 8. Cube root of 8 is 2. Negatives work, so the cube root of -1 is -1. And then we did +8, so now let's do -8, because that'll just be -2. So this pattern right here is for every cubic, just like this pattern right here to begin with was for every square root. So they stay the same to begin with. Then you just look to the front. We have no number in front, so nothing is changing this. So from this middle point, their turning point that we moved, we're going to go back 8. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Go back to this point. -1 means back 1, down 1. Back to your point. 1, 1 now means ahead 1, up 1. 8, 2 now means ahead 8. 2, 3, 4, 5, 6, 7, up 2. When you connect it, it should be this nice S-type shape on its side. And then remember, the turning point just means what's in the middle. It's just your left, right, up, down. So we went left 2, up 4. Domain, always infinities on the cubics, or on the cube roots, sorry, because it's going to keep going forever and ever. Your range, again, forever going down, forever going up. So when we are graphing these, just make sure you guys have this side pattern. So if it's a square root, your pattern is 1, 1. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. If it's a cube root, then you can do -8. Cube root of -8 is -2. Next one would be -1. Cube root of -1 is -1. Then regular 1. Cube root of 1 is 1. And then lastly, +8 gives you +2. So square roots can't take a square root of a negative number and get something real. So that's why we don't use negatives here. Cube roots, negatives can come out. So that's why it's on that one. Thank you for watching. I will see you later. Bye.